Hey, what's happening YouTube? Welcome to this presentation on open modules. I have a project set up here with a source directory and two modules in it and a build.sh which we'll take a look at in just a moment. So my com.py Nikolov, which is simply the reverse DNS of my domain, will be my main module, which has a main.java, which we'll take a look at in just a sec, and a domain package with a person. And then I have an XML package which has an XML Mapper which will take Java objects and marshal them to XML. And both modules of course have module descriptors. Let's take a look at these module descriptors. So my XML module exports its XML package, and my com.py Nikolov requires the XML module. So let's take a look at this main class. So my main class has a main method. Here I create a new person, John, age 27. Person is just a good old POJO, plain old Java object, with two fields, a string name and an int age, both private, and a constructor. So what I do is I give this person to the XML mapper and ask it to marshal the person. This mapper for now just returns a to-do in its marshal method with some sloppy error handling, like most XML mappers do. And I simply go ahead and print out the XML. Let's quickly jump over to the build.sh. This is very similar to the previous presentation of strong encapsulation. Remove my mods and mlib directories if they're there, create them again, then compile the code to the mods directory, tell the compiler where's the source code for my modules and which modules to compile, then create a jar named app.jar with my main class being com.py Nikolov main, and get the contents from the com.py Nikolov in the mods directory. And similarly do the same for the XML, and then just run the code. Java-p for module path mlib and -m for module com.py Nikolov. So let's go ahead and run it just to make sure we're all good. There you go, we get our to-do. So let's go ahead and implement this XML mapper and make it a little bit more interesting. So let's go ahead here and say object get class, and let's store that away. And let's get the class simple name. Then let's go ahead and make an XML, which we'll return, and we'll make an opening root tag. Let's add a line feed for good measure. And finally we'll finish off our XML with a closing tag. And then let's return the XML. So let's go and implement this one step further and add the fields of our object to the XML. So I'll say class.getDeclaredFields, and let's iterate through them. So let's make the fields accessible. We know that in Java, if you have a field and it's private, it doesn't really protect it from reflection at runtime, because we can always override the access as we do here. Then I'm going to go ahead and say string elem for element is going to be string.format. So let's open tag with a placeholder for string. The body can also be a placeholder for string. And here I'm going to just reference the first placeholder I used. So this $1 will just be the first substitution that happens. So I'll go ahead and say field.getName and field.get, name object to get the value. So let's add this to the XML and add some formatting. So I'll add a tab and a new line. Alright, let's go ahead and run this. So as you see here, we get an exception. Inaccessible object exception. Unable to make field private, here for my name, person.name, accessible. Module com py Nikolov does not opens com py Nikolov.domain to module com py Nikolov XML. So this is really a nice error message because it tells you exactly what went wrong, but what exactly does this opens mean? So by default in the module system, all your types are very strongly encapsulated by even from reflection. And in the previous presentation we saw about a module we depend on trying to access its private types. But here we kind of the opposite, where a module we're depending on is trying to access our types, in this case the person object. And in this case we want to allow this type of reflection to occur. So how do we go ahead and do this? So the simplest thing we can do, not necessarily the best, is to simply say open module. And what this does, it means every type in my module will be accessible to any module I depend on via reflection. So this is not the best thing to do, but let's make sure it works. Alright, that looks good. But we don't want to sacrifice this encapsulation, because you could argue that opening a module kind of takes away half the benefit of using the module system. But we can go ahead and make this one step better by opening just a single package. So I can say opens com py Nikolov.domain. Let's run it again, and that works fine. But we can take it another step further as well. We can target the opens or limit it to only a specific module. So here I can say opens my domain package only to the XML module. And let's run it again. And as you can see, that works too. So quick note here, why would we want to limit the opening of a package to a specific module? Well, in Java it's very common that we use frameworks and libraries that make use of reflection. For instance, Jackson for JSON, Hibernate for ORM mappings, and the Spring framework makes lots of use of reflection. Now what the module system allows us to do is to have very fine-grained control over which module and which types we want to allow reflection, or to which types we want to allow reflection. And one example here is we can say, for instance, we only want our domain package to be open to Hibernate. And then we might be able to identify code smells. For instance, if Hibernate is reflecting on types that aren't in the domain package, maybe we have misconfigured Hibernate, or we are cheating with our code, and as you can see, it might help lead to better design. So that's all I have for this presentation. Thanks for watching. See you next time.